Alright, so this is my first example of the product rule equation. So I did n of x times p of x, and my n of x was the root of x, and my p of x was x to the power of 7, and I defined this as h of x. First thing I did, as per usual, is to define n of x and p of x and their derivatives. For the purposes of this problem, I decided to keep n of x in terms of its root. Usually I make it a fractional exponent, but it made me confused later in the problem when I had to combine exponents, so I just kept it as a root. So n of x is root of x, and n prime of x is 1 over 2 root x. This is from some of the stuff that we've done in the past. We've done it a couple times, so I just kind of have that memorized. Then for p of x, I had to use the power rule. So I did 7 times x, and I got 7x, and then I took 1 away from the power of 7, and I got 7x to the power of 6 to get the derivative of p of x. So that's just the power rule. That's how I got that one. Then once I had all of these, I was able to use the product rule. For these terms, I did n prime of x times p of x plus p prime of x times n of x. Since it's addition, it doesn't matter what the order is. It will solve out to be the same thing. It'll all be the derivative of h of x. So now that I have everything defined, I plug it all in. So my n prime of x is 1 over 2 root x, and my p of x is x to the power of 7. Since it's a fraction, I made x to the power of 7 a fraction over 1, so that way I can combine, I can multiply across. X to the power 7 times 1 will be x to the power 7, so this can move over here. And 2 root x times 1 will be 1, so I can put this on top of here later in the next step. Then over here, I'm adding, I have p prime x, which is 7x to the power of 6, and n of x, which is just root x, so I have them multiplied together, and I'm adding it to the original term, and all of this is going to be my derivative. So, like I said before, I multiplied this across, so that way I could get one fraction, sorry. I made it one big fraction, since I had 1 on the denominator and 1 on the numerator. I could just multiply across and get one fraction. Then over here, there was nothing I could do, since I have this root. These aren't like terms, I can't combine them, they're stuck like this. So I just have this as my derivative, and it's my answer. But I'm not done with this problem because I decided to find my tangent line for this problem. So I actually went on Desmos and I made the graph so I could make sure that I found a real point. So the graph kind of looks like this. It kind of like curves up like this. It starts like a little asymptote, and then it goes up. So I actually found the point 1 of 1 does exist. So I decided to find the tangent line at the point 1, 1. So first thing I did was define all my terms. For a tangent line, my equation would be y equals mx plus b. In the equation, I'm finding 1 of 1, 1, 1, so y equals 1 and x equals 1. The slope, which is m right here, is equal to what I just solved for as the derivative. So I'm going to have to plug 1 in for x and solve that out. And then b, I don't know yet. So the first thing I did was I solved for m. So if you go over here, I'm solving for m. I plug 1 in for every time it says x in my derivative equation. So every time you see x here, I plugged in 1. So I have 1 to the power of 7 over 2 root 1 plus root 1 times 7 times 1 to the power of 6. So every time 1 is the power of anything, it's still just 1. And anytime 1 is rooted, it's still just 1. So really, it turns out to be 1 over 2, which is right here, so it's 1/2, and then this only means 1, and this only means 1, that's how it simplifies out. So this term right here just turns into 7, so you have 1/2 plus 7, which is 7.5, so my m and my slope in my tangent line at point 1, 1 is just going to be 7.5, that's going to be my slope. So now I'm going to plug in all my variables now that I have m as an actual term, and I'm going to try to solve for b so I can have my line. So I have 1, which is y, is equal to 1, which is x, times 7.5, which is m, and I'm going to add b.
So 1 times 7.5 is 7.5. I'm going to subtract it from both sides, so that way I can get b alone. So b is equal to negative 6.5. Pretty simple. Then I'm going to add that back in. Now that I have everything I need, my tangent line is y is equal to 7.5x minus 6.5.